Hello everyone, welcome back to my channel. Today we'll be covering Physics Unit 2 Electricity. The agenda for today is covering Specification Part A Units, Part B Mains Electricity, Part C Energy and Voltage in Circuits, and lastly Part D Electric Charge. So for units you need to be familiar with the unit of current, which is amperes, the charge, which is coulombs, resistance, ohms, time, seconds, potential difference, voltage, power, watt, and lastly energy transferred, which is in joules. You need to be familiar with these symbols too. Next up is electrical safety. So for the safety we have two devices. The first one is fuses. Now fuses stop the flow of current by melting their own wire and therefore melting themselves and stopping the current if it's too high. Because if the current is too high and components are functioning at too high a current, what will happen is that the wire will overheat and it can lead to fire. So like this, fuses protect sensitive components from overheating and prevent fire. Next up is circuit breakers. Now they also break the circuit if the current is too high, again preventing overheating and fire. Next is insulation and double insulation. They prevent people from touching exposed wires and getting electric shocks. Lastly is earthing. Earthing provides a low resistance part to earth. So if someone does come into contact with the current, what happens is that instead of current flowing through them to earth, giving them a shock, it flows to the earthing wire, preventing them from shock. Moving to the next slide, electricity and heat. Now when electricity passes through a component like a resistor or any component, what happens is that some of its electrical energy is converted to heat energy, which raises its temperature. This is because energy is transferred as a result of collisions between the electrons which are flowing in the conductor and lattice of metal atoms which are in metal conductor. Now in why the flow of electrons is called current and electricity is caused by current. What happens is that as current or as the electrons they pass to the metal lattice, they collide with the ions in the metal in the conductor, and electrons lose some of their energy by giving it to the ions, which start to vibrate more, causing the metal to heat. Because when they vibrate more, they hit the walls of the container more, and hence more collisions and more temperature. And then this heating effect is used in many appliances such as electric heaters, kettles, toasters, etc. All of the appliances that provides us heat, this heating effect is used there. Next up is selecting fuses. Now fuses come in a variety of sizes. They should always have a current rating that is higher than current needed by the appliance without being too high. Because if the current if the rating is too high, what will happen is that it will break the circuit it will not break the circuit in enough time before damage occurs. So damage will occur, and if it is too low, it will break the circuit even when acceptable current is flowing. So that's why you need a current rating that is higher than the current needed but not too high. For example, if you need if you need a current rating of, let's say, 10 amperes, so you'll select a fuse of 12 or 13 amperes. You'll not select of 20 because that will be too high. You'll not select of greater than 10 because that will be lower than the current rating needed. So take care of this point. Let's move to the next slide. Now here's a quote for you to keep going. Perseverance is the hard work you do after you get tired of doing the hard work you already did. So keep doing the hard work that you are doing. Next up we have power. Power is the rate of energy transfer or amount of energy transferred per second. Now the equation for power, which is in watts, is current, which is in amperes, into voltage, which is volts. So remember the symbol equation 2 and the word equation 2. Anyone can be asked. Next up is energy transferred. Now work is done when a charge passes through a circuit, and work done is equal to energy transferred. And now amount of energy transferred depends on three things. Firstly, current. Secondly, potential difference. And lastly, time. When charge flows through a resistor, energy is transferred is what makes it hot. As we just saw that energy is transferred which raises its temperature, and that heating effect is used in appliances. So that same point is repeated here, that the equation for energy transfer is energy transferred is equal to power into time, or another equation is energy transferred is equal to current, voltage and time. The simple equation is E is equal to I into V into T. Next up we have alternating and direct current. Now for direct current, it's a current that is steady. It's constantly flowing in the same direction in a circuit from positive terminal to negative terminal. It is not changing the direction basically. Now potential difference across the cell in a direct current circuit is also in one direction only. Current is only positive or negative and has fixed terminals, positive and negative terminals, and electric cells or batteries produce it. Whereas alternating current is a word alternating tells you that it is a current that constantly changes its direction, going back and forth around the circuit, and instead of having two fixed terminals, positive and negative terminal, it has two identical terminals that switches between positive and negative. Similarly, current is also defined as positive or negative depending on its direction at that time, and it is produced by electrical generators. Next up we have IV graphs. Now you need to be familiar with all of these, the diagrams as well as the explanation. So the first one is for fixed resistors and wires. So the relationship between them is a directly proportional relationship. There is a straight line going through the origin. As current increases, the potential difference also increases because resistance of the fixed resistor stays the same. If resistance starts to change, then the directly proportional relationship will also change. So remember this, and for graph you need to draw a straight line that is passing through the origin. Next up is filament lamps. Now for this, current and voltage are not directly proportional because resistance of the lamp increases as temperature increases. So as resistance changes, current also changes. Now this is because as current increases, temperature increases. When temperature increases, there are more vibrations. Atoms in the metal lattice of filament, they vibrate more collisions. So resistance increases, then resistance opposes the current, which causes the current to increase at a relatively slower rate as compared to potential difference. So this is the explanation, and the graph for this will be not a straight line going through the origin, but it will be a line going through the origin which is slightly curved. You can see in the diagram here. Next is diodides. Now diodides allow current to flow in one direction only, called forward bias. In the reverse direction, it has very high resistance. So as we just saw that resistance opposes the current, so very high resistance is there, it will oppose current and no current will flow, which happens in the reverse bias. As you can see in the graph, in reverse bias on the left hand side there is zero reading of current. So that is the thing that we have discussed. Moreover, a potential difference is on the left and current is also on the left hand side, which is reverse bias. On the right hand side, which is forward bias, the current is the direction of arrowhead symbol, and there is a sharp increase in potential difference and current both. Remember the graph and explanation. These are very important graphs. Next up we have the electrical circuit symbols. These are all of the symbols from your specification. You need to be familiar with them. The symbol for cell, battery of cells, power supply DC, power supply AC, transformer, ammeter, voltmeter, fixed resistor, variable resistor, diode, LED, LDR, thermistor, loudspeaker, etc. You need to be familiar with all of these symbols. You can be asked to use them in any diagram. Next up we have investigating IV graphs experimentally. So now you need to know that ammeter is used to measure the current, voltmeter is used to measure the voltage, variable resistor is there to vary the voltage or current, and power source is used to provide a source for the voltage. Now if you are being asked to draw a diagram where you have to measure the voltage of a certain component, you'll Draw a diagram similar to the one shown here, where you place the voltmeter parallel to the component, whereas the ammeter and variable resistor, if needed, in series. Make sure to draw a power source too. Component can be any one, it can represent a bulb, a diode, anything. Now there's another quote here to keep you going. It's hard work pays off in the future and laziness pays off now. So keep working hard. Next up we have series circuit. Now in series circuit, as voltage increases, current also increases. What happens is, in series circuit, current is same. It does not increase, it is same all over the circuit. Because number of electrons flowing per second through one part of the circuit is same as other part. So current is same throughout, but voltage and resistance, they are not same. Now the advantages and disadvantages of series circuits are that series circuit requires fewer wires, it is cheaper and is easier to assemble. Moreover, it uses less power and it can be controlled by a single switch. However, components cannot be controlled independently, and if one component breaks, they all will stop working. You can also see a diagram of series circuit here. Make sure to know what a series circuit is, how to draw their diagram, and that voltage and resistance, they are not same, but current is same throughout this the series circuit. Next up we have the parallel circuit. Now in parallel circuit, instead of current being same, here the voltage is same and the resistance and current are not same. What happens is here that total number of electrons in current going around circuit, they must be same, because electrons cannot be created or destroyed. So when they reach a junction, what happens is that some of the electrons go one way and some go at the other way, so current is conserved. This is the explanation for why the current is not same over here. Now the advantages and disadvantages are that components can be controlled independently, and if one component breaks, current still flows through other parts of the circuit. Whereas components, they all have the same voltages, so it is harder to control if you need to have different voltages. Make sure to remember these points. Next up we have voltage and resistance. Now potential difference, which is voltage, is equal to current into resistance. So you need to remember this formula, V is equal to I into R. Now since V is equal to I R, so as you increase the resistance in a circuit, the current will decrease. There is an inversely proportional relationship between resistance and current, whereas if you will increase current, the voltage will also increase. There is a directly proportional relationship between current and voltage, but inversely proportional relationship between resistance and current. Now fixed resistors have constant resistance, while variable resistor depends on the length of wire. The more the length, the greater the resistance. Next up we have volt is joule per coulomb, whereas voltage is energy transferred per second. Remember these points too. And next up we have another equation, which is potential difference is equal to energy transfer divided by charge. V is equal to E divided by J. Next up we have charge. Now charge is equal to current into time. The simple equation is Q, which is the symbol for charge, is equal to I into T. Now current is the rate of flow of charge. Now you might be confused that earlier we said that current is the flow of electrons. So remember that it is the flow of electrons in a wire, but otherwise it is the rate of flow of charge. So current is equal to charge divided by time. Next up we have lamp and LEDs. Now lamp and LEDs can be added to a circuit to check for a current. You can add them to see if a current is flowing through a circuit. If it will be flowing, it will light up. The lamp will light up. Now the relationship between resistance and temperature in LDR is that as illumination increases, as light intensity increases, resistance decreases, whereas in thermistor, as temperature increases, thermistor decreases. So there is an inversely proportional relationship. You can see a graph too on the left hand side. Next up we have electric charge. Now There are few conducting materials which conduct electricity and few insulating materials which will not conduct electricity. Conducting materials include copper, aluminium. Insulating materials include glass, wire, and many more. Next up we have a practical, which is about investigating how insulators can be charged by friction. So you'll hold polythene rod and cloth next to up small pieces of paper one at a time. Then you'll observe it. Then you'll rub the rod with the cloth. You will again hold close to small pieces of paper. You'll observe. Then you'll turn on the tap so a thin stream of water is flowing. Then you'll hold the rod about 1 centimeter away from the water just below the nozzle, and then again you'll observe, and finally you repeat with different material rods and cloths. Lastly, we have the dangers of electrostatic charges. Now, as aircraft fly through the air, friction causes them to become charged with static energy. Now, static energy is very dangerous. What happens is that after an aircraft has landed, there is a possibility of charges escaping to Earth as a spark or flash of electricity. If this takes place during refueling, it can also cause an explosion. So the solution to this is earth the plane with the conductor as soon as it lands and before refueling begins, allowing the charge that is built up to flow to Earth. Moreover, fuel tankers, which also transport fuel on roads, they also need to be earthed before any fuel is transferred to prevent any sparks causing a fire or an explosion. So this is all for this unit. I hope these slides were beneficial. Thank you so much for watching. Take care.